Section 4.2, solving absolute value equations and inequalities in one variable. So we're going to start with solving this. Now remember, if we were to have, for example, absolute value of x equals 3, that means inside here we could have had a 3 or a negative 3, because either way when we took the absolute value, we'd get a positive 3. So we'll use the same idea over here. This 2x minus 3 can equal 7, or it could equal negative 7, because then when we would take the absolute value, we would get a positive 7. So now we just solve these. So x equals 5 or negative 2. Now here, the only difference is we have this plus 4 in there. We need to get this absolute value by itself first. So let's go ahead and do that by subtracting the 4 to both sides. So now we'll have the absolute value of 7x minus 2 equal 1, and we can break it up the same way we just did and have the positive and the negative. Because remember, that could be positive 1 or negative 1, because either way, when you take the absolute value, you'll get a positive 1. And now solve. So x is 3/7 or 1/7. Both of those will work. Now, this looks different because both sides have absolute value, but it's going to work the same way. We still break it up into the positive and the negative. Because notice, if we took the absolute value of this would be a positive, and so would that. Now we just solve each of these individually. So x equals a negative 6 or negative 1. Now we've got an inequality with less than 4. Notice this number in here, when we take the absolute value, needs to be less than 4. That means it needs to be somewhere in here, but we can't get too much farther than, this negative 4, because once you start taking the absolute value of numbers over here, it becomes 5, and we need the absolute value to be less than 4, meaning this whole piece needs to be between here and here. So what that means is this 3x plus 2 needs to be less than 4, and it needs to be greater than negative 4. And so one thing to remember, you'll just rewrite it the same way here without the absolute value. And then on this one, we'll switch the sign and make it negative. And you have to remember this and in the middle. Now we'll just solve each of these. Now remember, we've got inequalities, so we need to graph them on our number line. This first one, if we wanted less than that, we'd be going this way. The second one, so our answer is from here to here. And in interval notation, that'd be from negative 2 up to 2/3. Now let's look here. We've got the absolute value of 3x plus 4 is greater than 13. That means if we had a number line, this 3x plus 4 needs to be past 13, but then because we're also taking the absolute value, it needs to be past it on this side too, so that when we take the absolute value, it's greater than 13. So now we need this 3x plus 4 to be greater than 13, or we need it to be less than negative 13. So once again, notice from here to here, we changed it to a negative, but then also changed the sign. So each time you're going to be changing the sign and changing it to negative. Notice though this time also we use the word or, and we'll get to a short summary on the next slide. But now we'll solve these just like we have been. And then once again, remember we've got to get our line graph. Graphing this first one, second one, and remember it's or, so it's where there's one or the other. So we'll have from negative infinity up to negative 17/3 union with 3 to infinity. Now, our nice summary. So we used the word and. Remember before we had our less than, but then we also used it with less than or equal. And or would then be the other two, but then also when we have an equal in there with absolute values. And these are with absolute values. So now we're going to go ahead and solve this inequality. So remember we break it up. Remember, switch the sign here and switch the sign for the 13. Notice it's a less than, which is in our and. So we'll have the word and in there. And now we'll just solve each of these. Once again, we got to graph it just to see where our answer actually is. Well, now notice for and we need where we have both lines. And we don't have both lines anywhere. So this will mean no solution. Notice though, back at the beginning, we wanted when an absolute value is less than a negative number. And we all know that absolute values are positive. So this is, if you catch that right away, you can go straight to no solution. Because an absolute value is never going to be less than a negative number. And now this is all for section 4.2.